A malfunction that we may sometimes encounter with a cooktop is when the flame of a particular burner or multiple burners does not stay lit. As we all know, each burner is equipped with a thermocouple, a safety valve whose function is precisely to prevent gas from escaping if the flame goes out accidentally, or to allow gas to flow when we are using the burner and the flame is on. However, in some cases, when we go to light a particular burner and then release the ignition knob after a few seconds, we see that the flame on that burner goes out. This is clearly due to a defect in the thermocouple, which we will need to replace. In some cases, however, it is not always necessary to replace the thermocouple. In fact, it is important to recognize that it is not always a defect within the thermocouple itself that causes this issue. Rather, oxidation can gradually build up around the area of the thermocouple at the point where it is attached, and this oxidation prevents proper communication. Therefore, in this video, we will see how to restore and remove the oxidation so that the thermocouple works again, and also how to check if the thermocouple is actually not functioning and thus needs to be replaced. So let's start by seeing how to address and resolve the specific issue of oxidation on the cooktop. And once we have completed that step, we will do a practical test using a tester to accurately determine if a thermocouple is working correctly. To address the oxidation that has occurred on a thermocouple, you need to unscrew the small bolt that secures the thermocouple at this specific connection point. Then, once we have successfully done that, using a flathead screwdriver, we carefully remove all the accumulated buildup. That is to say, all the oxidation that has gradually formed at this spot. This way, when we finally go to reinsert the component, the small bolt, we will have proper contact, and therefore the thermocouple will once again be able to function properly. So using a screwdriver, we carry out this type of cleaning procedure. Clearly, the process may take more or less time depending on the amount of oxidation we might find at this point here. So we always clean thoroughly using the tip of a screwdriver. In this way, we could also use a small steel wool pad if needed, or in any case, whatever we have available to thoroughly clean all the oxidation that has formed in this area here. At the same time, we also give the screw a light cleaning like this. Okay, that looks great, and once we are completely finished with this step, we can carefully screw that small screw back into its original position. So we tighten it all the way down. And then, starting right from this specific point in the process, if it turns out that the thermocouple's persistent malfunction was actually caused by a buildup of oxidation, you will find that the thermocouple will gradually begin to start working properly once again. Now let's see, in practice with the help of a tester, how to carry out a test, that is, how to check if the thermocouple in front of us is working. To perform this type of test, we will use this thermocouple, which is basically a new thermocouple, and we will actually check if it works. To do this, we will use a tester, which we will initially set for a first test to the ohm scale at the lowest setting, like this. Therefore, we will insert one probe of the tester. We will insert one probe of the tester into this spot. Here, so into the connector, while the other probe will be placed here at the fixing nut, let's say, where it is positioned on the cooktop. We can see that it gives variable results. So, there you go. So, let's say we have continuity and therefore the thermocouple is working. Now, in order to carry out a much more thorough and further check at this specific point in the process, we are going to carefully move the probe over to the 1000 volt scale, while ensuring it is positioned at the very lowest possible setting, just like this. We position the probe in the same way, on the nut here, okay? And in this case, Therefore, we don't see any movement at all. So with the help of a lighter, we need to heat up the tip of the thermocouple like this. And we can see on the tester's display how the value starts to rise. This happens because the tip is heating up and therefore is sending a signal corresponding to the heating point. This occurs because the tip is heating up and so the value increases. If we let the tip cool down, we can see how the value detected on the tester decreases. This allows us to understand that the thermocouple in question is working properly and can therefore be safely installed on a cooktop.